Okay, day number 7 today. And this is going to be looking at, what we're going to look at today is just the shape of the normal distribution curve. And we're going to do some example problems involved in that as well. So, the basic curve, if you're looking at a normal distribution curve, so I'm just going to use the line tool here. So if this is our bottom line, and then here is our frequency. Okay, our frequency is going to be the y-axis. On the bottom here, we're going to have our x results, our data points. Okay, so what happens in a normal distribution curve is right in the middle is the mean. Okay, that's the highest point. Now the book uses a funny U like that to mean mean. We also used x bar. So they interchange x bar with the mean, so don't get confused on that one. And then what they find here is that one standard deviation away on either side is most of your data. So if you kind of take a dotted line, and we just draw a little dotted line here. So one standard deviation, so here and here. Okay, and we're going to draw the shape of the normal curve here right away. And then we're going to have another standard deviation away. So we're going to have another line here. It's going to be a little lower. And another line here, same height. And then finally, we're going to have a small line here and a small line here. And then it's going to curtail off. Okay, so our normal curve is going to look like this. Okay, and our mean is going to be the highest one. So I'll do it in green here. It's kind of going to come. The highest point is at the mean here. Okay, and it might be a sharper bell than this. Okay. This is our normal distribution. I'm going to do it on a little bit skinnier line so it's a little bit neater. So this is our normal distribution. Okay, and right in the middle here we have our mean. So this is that's our mean at the high point of the curve. So 34% in this region here, one standard deviation away is 34% on either side, just over a third. So this is one standard deviation. This plus would be U or mean plus one standard deviation. Okay, so this would be the mean plus the standard deviation. Okay, I did that one backwards. Let's fix that. Okay, this would be the mean plus two standard deviations. The mean plus two standard deviations. And finally, this would be the mean plus 3. Okay, so that's a standard deviation symbol that I'm using there. Okay, so this would be 34% there. So that means in this region there, we have 68%. After that, this is 23. sorry, 13.5%. I almost said 30. Okay, and that's the amount of data. So as you can see, and then the last little bit here, this is 2.35%. So if you were totaling everything up, if I move right up above the top, in between one standard deviation from the mean, this whole part is 68% of the data. So 68% of the data in a normal distribution is within one standard deviation of the mean. Okay, and the higher the curve goes and down, the sharper it is, the smaller the standard deviation is. The lower the standard deviation, the more flat the normal distribution will be. Okay, from 2 standard deviations away, if you look at that, that's going to be 95% of the data. So from here all the way to this one, 2 standard deviations on both sides. So that adds the 13.5, the 13.5, the 234s. That's 95% of data. So there's only 5% of the people or data points that are above 2 standard deviations or below 2 standard deviations away. Okay, so then as you go to the 3rd standard deviation, if you go that way, all the way from here to here, that adds on the extra 2.35 on both sides, which would be 4.7. So that's 97 or 90, pardon me, 99.7% in our way. So that's the 3 standard deviations there. Okay, so if you're thinking about that, that means if you're 3 standard deviations above the population in something, you're in the top 0.3%. If you're 3 standard deviations below, so the only thing that's left is about 0.3%. So what's left for beyond is just in this area here, there's just 0.15% left for the rest there, and 0.15% left for the rest here, below 3 standard deviations away or above 3 standard deviations away. Okay, and you can see this on page 250 of the text. They summarize it in there with a picture. Okay, you don't have to remember this distribution. You can always reference it. Okay, on a quiz or a hand-in, you'll have the data there to look at, and you can use that. So now, how do you do questions with this basic form here? Well, basically, they'll ask some particular questions using standard deviation formula, okay? And they'll ask you for percent values or values of different types of things. So let's look at the 2 or 3 different types of questions that there are. Okay, so we're going to memorize this, or we're going to use this, so you don't have to memorize it, but you can reference page 250. Okay, so I'm going to flip the page ahead here. I'm just going to bring my preview up because I don't know how long I'm going here. So about 8 minutes. So I want to keep this in that 25-minute range here. So we'll put that over here. Okay, so let's look at some example questions. Okay, using the normal curve pattern to solve problems. Okay, so example 1. Okay, so let's get a example here. Let me just pause here and find a decent one. Okay, so here's example 1. So this is just you given some data, not that you have to figure it out. So we'll call it given the mean and standard deviation. Okay, so let's go with the members. Let's go with dart club. The members of a dart club have an average or mean age of, let's say, 50 years old. With a standard deviation of 1.5. Let's go 2.5. Let's make it a little bit. 2.5 years. Period. Okay, so it gives you that, and then we'll ask some questions. A. Okay. What percentage of dart club members are between let's go 45 years and let's go 52.5 years. Okay, and we'll do another one here. Let's go. What percentage of club members are over, let's say 42.5 years of age. Okay, and we'll do one more here. Actually, that'll probably be enough. Okay, so what you do here is you draw your basic normal curve shape that you have, or you can just reference page 250. So the first thing you do, what I usually do is I draw a little sketch. Okay, and then my mean is going to be in the middle. Okay, so my mean according to this data is 50. So 50 is here. Then that's the mean. And then one standard deviation is 50 plus 2.5. So that's one standard deviation is 52.5. Two standard deviations is another 2.5 years. So that would be 55. And three standard deviations is 57.5. Okay. And then if we go backwards, one standard deviation below is going to be 47.5. So you can see where I got these numbers from. And then two standard deviations below is going to be 45.0. And then three standard deviations, 1, 2, 3, three standard deviations right here is going to be 42.5. Okay, so then if we draw a normal curve here, that wasn't very symmetrical. Let's try that again. Okay, so I'm going to put my mean right there. These two things are going to be a little lower. These ones are going to be a little lower. I'm going to make some dots so that I can kind of draw it in here. Okay, so the first question it asks us is from 45 to 52. So from here to here. Now, if you reference page 250, and you know that this is 34%, this is 34%, and this is 13.5%. So that's going to be for A, it's going to be 13.5% plus 34% twice. Okay, so if you add those all up, that's 68, 78.5, 82.5%. Or wait, set 68, 78, 81.5%, sorry. Now, if I said there were 1,000 members, you'd have to multiply that by the percentage to get the specific number. So I didn't say that here, but the next one is, what is the percentage that are over 42? Well, over 42, this is 2.35, and this is 13.5, and this is 2.35, and 0.15. So basically, it's everything except for this last standard deviation away. This is 1, 2, 3 below. So over this value, it would be everything except for that 0.15. So it would be 100 minus whatever all this is, which would be 99.85%. Or sorry, I got it backwards. I'm just adding them. It's 99.8. If we add all of these there, you get a total of 99.85%. So just about everybody's over that age. And that's the first type of question where they give you the results. Now, the other thing that they might ask you is, they might ask you to analyze two different results as well. Okay, so we'll look at an example like that. Okay, so that just reminding that the normal curve, this is 1 standard deviation, 2, 3, and then beyond that, 1 below, 2 below, 3 below, and then beyond that. Okay, so second question that they're going to ask, example 2. Okay, I will show you. Just let me pause this for a sec. Okay, so the second example is just going to be like a warranty example that you can use in these. Okay, so let's say a watchmaker makes, let's say, watches that last 5 years, or let's go more than that. Let's go 10 years with a standard deviation of 2 years. That's your setup of your equation there. And then let's say the warranty or the manufacturer wants to have no more than 2.5% of the watches returned warranty. How long should the warranty be? You basically have to where's my marker here? There it is. Okay, so we basically have to set up our standard deviation table. So okay, so here's our mean, which is 10 years. And then one standard deviation away is 8, right? Then 6, then 4, 12, 14, and 16. So they want 2.5%. So 2.5%, the ones that don't last long enough. So 2.5% would be up to here. Remember, this is 2.35, and this would be 2.5%. So this is the ones that only last less than 4, less than 6. So therefore, if they were to have a 6-year warranty, okay, would produce only 2.5% return. Okay, and if it was an 8-year warranty, then you got this extra 13.5%. If it was a 10-year warranty, well, you're going to be returning half your stuff on warranty. Okay, so the other kind of question, the third type of question that they ask is whether or not, which we'll do next day because we're getting to about 25 minutes here. I'll give you some practice. Is when they give you a bunch of data and they ask you whether or not it's normally distributed or not. So we'll look at that next day. I'm trying to keep these around 25 minutes. Okay, so these two types are just using the normally distributed curve to find out how much percentage you have. Okay, sometimes they go opposite way as well. I should do an opposite one. I think, well, no, actually they don't. Okay, so let's just do a couple practice. Okay, so on page 251, 253, you can try 1 and number 2. Okay, number 2 is a comparison. It says sketch the normal curve for test 1 and 2. Okay, examine the graphs. What do you know how they compare? So you're just doing a sketch there. Okay, and number 3, you're just looking to see the shape. Okay, remember you want to see when you kind of do that frequency distribution, the mean is going to be in there, so you want this shape in here. Okay, let's see if it is or not. Okay, and then there's a couple more there that we can do. You can do number 6. Shouldn't take you that long. Then you can do number 11. I think is the same, yeah. Number 11 and number 13. Okay, and then next day we'll look at looking at a whole set of data and then converting it into seeing if it's normally distributed or not. And then we'll do a couple days of Z scores, and then we're done this unit.